All right, here we go. We got to change some things on this thing because I copied and pasted this from your ebook. So a fish is reeled in at a rate of 2 feet per second from a bridge. So pretend that that boat is a fish, okay? It's a big fish. Done. All right. So a boat is reeled in. That's awesome. At a rate of 2 feet per second from a bridge 16 feet above the water. At what rate is the angle between the line and the water changing when there are 20 feet of line out? Yeah. Go to dreads. Immediately, let's draw our pieces. Okay? And what I see here is pretty much, this is the most important thing that I should be looking at. Okay? And of course we know that it is a right angle right here. Because it won't tell you, hey guys, use a right triangle and stuff. No, you have to come up with all this from the experience and practice. Here we go. If I looked at this, let's give it some variables. What could I give these variables? I could give it x, y, and z. This is what I want you to do with triangles. X is horizontal, y is vertical, z is the diagonal. Please do that for the sake of consistency. Don't use A, B, and C, even though I know that's the Pythagorean theorem. Please use X, Y, and Z. All right. Do we know anything that, what else can we add to this picture from the reading? Y is 16, right? So let's do that. Y is 16 feet. And Z is 20 feet. Okay? I think I heard it. It's okay if you didn't see it yet. I'll show you in a minute. The diagram is done. Rates that are given or unknown. I'm going to throw you right into it, guys. What rate, Drew, are we given? 2 feet per second. Is it a positive or a negative? So if it's reeled in, Z is decreasing. That's huge, because otherwise one negative, you missed a lot of points that it goes to, okay? And I will not sit there and see, would they have gotten this right if it was a positive? I'm not going to create two keys, so please make sure that you understand the level of those negative mistakes have to refine big time in this unit. So negative 2 feet per second is what? Drew? Go for it, Matthew. What is it? dz dt. The rate of change of my hypotenuse in respect to time is a negative 2 feet per second.
So we can basically make anything?
Yes.
Yeah.
Yes.
Okay.
Yeah. So there's a lot already of, oh, okay, that's what we're doing. Grant. We're still doing rates. What rate are we looking for?
The rate of change of the angle.
Okay.
So like d theta.
So it'll be d theta over dt is equal to something when what, Grant? When z is equal to 20 feet. Already, this is different. Again, we're going to have to think of everything that we've been taught. So what we're looking for, in case you haven't already figured it out, we're looking for this. And we're not looking for the angle, we're looking for the rate of change of that angle. At the exact moment, picture in time, when z is 20 feet out. Are we good? Okay, here we go. From all the pieces, listen, ask yourself this question. Relate all your pieces together.
Use sine.
Sine is what we should use. Because if you choose the wrong equation to use, you can make it very difficult. And it'll be longer to get your answer. Sine is what we're going to use. Okay? So here we go. The sine of theta is equal to what variables? Y over z. Here we go. The most important two questions. Question number 1. Is theta changing or constant? It's changing, so I should leave it as a variable. Question 2. Should I change theta to something else? No, because how else will we ever be able to get d theta dt piece? Let's use y. Is y changing or constant? Constant. Because it's constant, we're going to plug in right now, before deriving, we're going to plug in what? 16. Is z changing? Yes. So I should leave it as a variable. Should I leave it as z or change it to something else? I'm going to leave it as z because how else would I ever be able to use this piece that they were giving me? Raise your hand, honestly, if you understand the two questions. Okay, those are the most important questions, okay? This will make it easy. Here we go. Let's take the derivative in respect to time of exactly what we see implicitly right now.
Real quick, if it's changing and it gives us a value, can we leave it?
If it's changing and it gives us a value, we leave it as a variable. Very important. If it is changing and they give us a value, don't put it in until we're ready to use it. But still, if it's changing, leave it as a variable. Did you hear that question? All right, the other thing is this. Y'all were asking me earlier, is it implicit or explicit? Look at this. This is explicit, even though it's still d something dt. But I was looking for dv, or actually, it was explicitly given to me as the volume. But I wasn't looking for the volume. I was trying to look for dh dt. You with me? This one is implicitly given to me because there's not a variable all by itself. But it doesn't matter. Implicit or explicit, my goal is to substitute and solve at the end. Okay? All right, Evelyn, what's the derivative of the left side? Cosine theta times
Would it be the derivative of theta over 3?
yep, d theta dt is equal to, now look, I have 16 over z. I'm telling you, be honest, how many of you would do quotient rule? It's a little bit too much work if you try to do quotient rule, okay? Looking at this, I'm going to bring this up as a rewrite because of two things. The top numerator, what? Is one term, and it's a constant. So now the derivative, Madeline, of this is going to be what?
-16d
To the negative 2, keep going. dz dt. Guys, I'm going to move it right now. This z to the negative 2, I'm going to move it downstairs. And just like Madeline said, I still have to remember my dz dt. Okay? Alright, here we go. We're going to plug in dz dt with a negative 2. We're going to plug in z with 20. We're doing substitute right now. I'm looking for d theta dt. That's my unknown. But I still have a variable right here. I still have cosine of theta. So what should I do? Okay, arc cosine of whatever the side is. Do you see how right now in this triangle, guys, I have 16, 20 theta? What I could do is say the arc sine, you with me? Look, this is the hard way. The arc sine of opposite over hypotenuse. This will give me theta. Raise your hand if you agree. Yeah, this will give you theta. And then take the cosine of that. That's the hard way. I think the faster, easier way would be this. 2016 is like a 3, 4, 5 right triangle. So it's 12. Because all of these are by a factor of 4. So it would be a 3, 4, 5 right triangle. You see how we did that? And all I cared ever, this is the one that it's easy, but you can make it hard. This could be a level 7 because depending on what you know and how you try to work this out. Instead of doing this and then taking the cosine of that, no one has time for that. Just solve the triangle and ask yourself, what is the cosine from this angle? 12 over 20, which is the same as 3 over 5. So 3 over 5 times d theta over dt is equal to, let's plug this all in, negative 16 over 20 squared times negative 2. And this would be without a calculator. So I get a positive 32 over 400. And what am I going to multiply both sides by? 5/3. That cancels that to a form of 1. And what do I always do before multiplying straight across? Simplify. 5 over 400 is what? 1 over 80? 1 over 80? Does anything else simplify? You can simplify more. 32 over 80 can simplify, like they both have a what? An 8. So this is 4 and 10, and you could still keep going. You see what I'm doing? That's easier. I'm telling you, for the speed that you're going to have to do these problems in, 4 over 10 can reduce to what? 2 over 5. So now I'm left with 2. Whoops. 2, 1, and come on. 3 and 5. So that the answer is what? 2 over 15. d theta over dt is 2 over 15 what? Here's the thing. Radians per what? What's the time? Seconds? Because calculus is so radical, we're always in radian form. Okay? We're never ever in degrees. Physics is, but calculus is not. Make sure when you take your physics, raise your hand if you're taking physics C. Guys, there's been people that scored 3s instead of 5s, or even 4s instead of 5s, because they were in the wrong mode on the calculator. Physics is in degrees, calculus is in radians. Okay? Any questions before we keep going? Again, this was like a level, in my opinion, like a level 7. Because there's a lot of easy stuff that could go wrong. Okay? Is it 1, 2, or 3-dimensional? The angle, the way it's changing, it's not 2. It's not an area. It's like a rectilinear angle, but it's at like an arc.